Okay, well, as you are getting yourself organized, as you are checking your name off the attendance list, I want you to know what's going on here. I have a Zoom meeting turned on here on my computer that's recording the whole session. So that means that it's going to record everything that I'm teaching you. And what I do is I will take the lessons and I'm going to convert them into a YouTube video and put it on my channel. And then you can review. Does that make sense? So you don't need to, I think it's important that you take notes while you're doing this. But what the way you think about taking notes is not jotting down everything so that you don't miss a word, but rather when you're taking down notes, use it as a tool, as an additional tool to process your thinking. It's a very different idea. Taking notes is not just so that you can capture things. Because right now people can use phone to capture the notes, so it doesn't really matter, right? What matters is that when you're using your hands and your pencil, the movement on the tactile movement on your hand is going to bring neural connections in your brain. Okay, it's going to help you think. And the way I write the notes and how I solve solutions, I want you to mimic them, because there's a reason for how I write things out, because it will help you organize your thinking. This course is going to get more complex in terms of concept, and it's going to lead to pre-calculus and calculus later on when you take them. Problem is going to get more complex for your brain to hold everything. So when you're writing things up in your solution steps, it is a way to hold your thinking together so that you don't miss anything, right? Your brain is a bucket, but sometimes it's a very leaky bucket. You can't really hold everything. So your writing the solution steps is going to help you think through the problem more precisely and more accurately. Make sense? All right, that's number one. Number two, so we will record, you will be able to review the notes. Number two is that the way we learn here is I'm going to basically point a fire hose of information at you every Wednesday. We're going to go fast. We're going to go fast. There's going to be a lot of materials. You're going to have time to process as we go through this, but you had to be with it. Because if you don't follow, if you're not with the conversation and the discussion, you will miss it. All right? There's a lot of stuff going on. All right? So we're going to do that very, very quick. All right? Number three is that your assessment, how I assess your learning and your grade, comes from what you can produce. Comes from your actual skills. And that can only happen on tests and quizzes and final exams. That's it. In fact, I'm not going to even give you quizzes. I'm going to give you a test at the end of the unit. And that's your grade. I'm going to give you assignments or practice questions for you to take home and practice. But I'm not going to grade them because I don't have time. I need to run the whole school. So I don't have time to grade your assignments. But besides, assignments, they're meant to give you the time to practice so that you can perform well on the test anyway. Okay? Well, what's the next point? Next point is this. So you say, well, what if I didn't do well on the test? Then my test is going to, my grade's going to tank. Well, yeah. But I'm going to give you chances to make it up. So you take a test, and then you say, well, I didn't do well. Okay, well, I'll give you one more week. Next week, you're going to find a separate time with me. I'm going to hand you a different version of a similar test. And you're going to take it again. And if you get a better score, that's going to be your grade. Make sense? Why? Because I believe that you all learn at a different pace. Some of you, as soon as I present, you know how to do this. Some of you, when I present, you really have to think deeply and process them. Sometimes it's not going to be within the same timeline as I give out the test. Maybe you need just extra 2 more days or 3 more days. So it's really about you eventually mastering the skills. And whatever you end up to be, that's going to be where you are. Does that make sense? So I'm testing your mastery. You had to gain mastery in order to get good grades. Some of you can get mastery without doing a lot of work. Good for you, lucky you. Some of you can get mastery by doing tons of work. Good for you too, because diligence will pay off. Make sense? Now, if we're in an ideal world, I can give you infinite number of retakes so we can get that mastery. But the truth is, we don't have that kind of opportunities or time. So I'm going to give you at least one, maybe at most two retakes. Does that make sense? But every time you take a retake, make sure you think about mastery. Learn the content, learn the skills so you can solve the problems. Got it? Any questions so far? So I'm going to continue to organize and communicate with you through my PacBay. You all have access to my PacBay, right? So if I put an announcement, you'll get it, right? Make sure you check them, okay? That seems to be my primary way of communicating with you. If that doesn't work, if you say I need an email to remind you, sure, maybe I can do that later on. But right now, my primary communication channel with you will be through my PacBay. Okay, now, so I understand that you guys are going through chapter 2, and some of you, maybe a couple of you, are already moving ahead, but most of you are in chapter 2, right? Quadratic. Okay, so I'm going to actually spend just brief amount of time to kind of give you a basic approach in thinking about math. Now, by the way, I've been teaching over 25, 27 years of math and science. Every possible math courses you can think of, I taught. In fact, for about 12 or 15 years in a row, every year I teach AP Calculus A, B, and BC. I had 100% passing rate for all of my students. Okay, I even this is what I even do. I tell my students, I say, hey, you had test questions for APs go all the way back to the 1970s. I'll do a challenge with you. You can pick any problem from on the internet, put it on the wall, put it on the board. I can solve any of those problems in 5 minutes. In fact, I can do that. And that's why every time I design a test, I will do it myself. If I can finish in a certain amount of time, I multiply by 5, that's the amount of time you will take. That's how I gauge how rigorous that test is. Okay, so that's enough about myself. Let's start with this. Okay, a little bit of an intro. Because I don't know your skill level, so I'm going to go back a little bit. I'm going to go back a little bit very quickly, and then we'll catch up to where we are at today. Basically, we will approach math or Algebra 2 in 4 ways. What are the 4 ways? Well, first of all, you have to be able to visualize. Right, so this is called graphically. So you have to be able to, any concept you learn, you have to ask yourself, can I visualize this? If you can't visualize this, you have to ask me, well, how can I visualize this? In every single concept, no fail, you have to be able to visualize. On a graph, how do you put it in your head? Okay. Number 2, right, you have to be able to use, right, simple. Algebra symbol. Right, so these are basically X, Y, and Z. Why? Because this is basically, well, algebraically. This is basically we have to be able to solve problems, solutions, and all that stuff. These are basically the articulation of the logic so that we can apply this generally. Okay? Number 3, use numbers. So now, it's no use to have algebra solution when we can apply to numbers, because numbers is by way of approximating. Sometimes, some of you, I can tell, right, based on years of teaching, I know that some students are more attuned numerically, like numbers. You know, the kind of students that you, when you're going through elementary school, middle school, those are kids who can like just do things, do math in their head. They think numerically. But doesn't mean that when you think numerically, you can translate that into algebra. In fact, I'll tell you a secret. I'm very terrible with numbers, but I'm really good with symbols. That's why when I was in college, I studied theoretical physics, because it's all about symbols. I'm not in engineering, because engineering uses a lot more numbers. You see what I'm saying? So, but again, the idea is that in this course, you have to be able to tackle these problems in all these different ways. And number 4, lastly, is be able to talk about it. You have to be able to talk about it. One best way to learn and know that you got the concept is when you can teach to another student. Does that make sense? 4 different ways. All right. Now, in this course, we're teaching first one, straight lines of various directions. Right? So this something like this. Right? So these are what we call the linear function. Number 2 is where you are at right now. Where you're at right now, you're learning about parabola. And parabola will look like this or this. Right? And these are what we call the quadratic functions. Okay? I'm giving you the lay of the land. Number 3. Now, the reason why I do that is because I think it's important when you go into a course, you kind of get a sense of what you're learning. And it helps as you learn the details. Number 3, you're learning about this kind of a curvature in a higher degrees. Right? So they will look like this. They will look like this. They will look like this. Right? Things like that. These are what we call the polynomial. Polynomial functions. So this will be to the x to the 3rd power. These will be to the x to the 4th power. Okay? So typically this will be, if you think about this will contain x to the 1 power. This will contain x to the 2nd power. These will contain x cubed. This will contain x4, x4. Okay? And number 4, we're talking about rational function. Rational functions, they look like this. They look like this, something like this. Different variations of that. And they are usually this kind of function, 1 over x. It could be 1 over x squared, 1 over x cubed, but nonetheless, it's rational function, which is basically a fraction, right? In a fraction form. And lastly, number 5, this is growth and decay. Growth and decay This is what we call the exponential function. They look like this. And what kind of functions are these? These are something like maybe like y equal to 2 to the x, or y equal to 10 to the x, or or e to the x, things like that. Guess what? This is it. This is it. This is everything you need to know about Algebra 2. Of course, we have to fill out the details, right? In fact, this consists of 6 chapters. So we'll go through chapter 6, unit 6, and that's the whole course.